Hello, everyone. Welcome to another video here on using the risk management and decision-making simulator. Let's dive into it right now. We're going to start fresh over here. And let's see what we have in store today. I'm going to stick with the RMM framework. Certainly one that I'm used to. We'll perhaps go into a T-DODAR next week, but let's stick with the RMM. And let's have a look. The weather in Cape Town has been absolutely atrocious the last few days. So let's try to find something out of Cape Town. Here's something, Cape Town to Joburg. So this one, relatively... Yeah, maybe this might work. SAFE 295. My mom's actually on a flight there today. Let's have a look at this 295. So Cape Town weather, what's it looking like? 8,000 meters, light rain. What's the wind? 32018. It's not too bad. 8,000 light rain, scattered 500, broken 2,500, 17 and 16, 1009. No SIG. OR, it's good here at the moment. I'm actually in OR at the moment. So 23012, Cavoc 18, 1023. So now let's give this one a go. It looks like they're just in the climb, actually climbing through 13,000 feet. And we're going to choose a scenario today. First officer level, let's go... what should we choose? Let's go mechanical systems. We'll choose an amber difficulty, and let's let it generate the scenario. So those of you tuning in, clicking into this, this is a bit of software that's part of the Bryan Air ecosystem, and my big passion in aviation training has sort of by default become the management of abnormal situations and trying to help pilots actually develop this skill. When you come for simulator training, you're thrown into the sim, but you don't get many opportunities to actually practice these things. So this is a little tool that I made to help practice the decision-making around an abnormal scenario. And it uses a bit of AI to help create a fictitious scenario, which it's done here. It's taken a SAFE flight. It's a 737-800, departed Cape Town, climbing through 13,000 feet, passing over the eastern shore of False Bay, roughly 30 miles east of Cape Town. The aircraft's tracking 069. It's nowhere near cruise altitude yet. Departure conditions were marginal with light rain, low scattered cloud at 500 feet, broken layer at 2.5, and the aircraft's likely still threading through a few cloud layers. About 2 minutes ago, and this is where the fiction part comes in, this isn't actually happening. It's creating this scenario, but it's using a real flight to create this scenario. It says about 2 minutes ago, the crew noticed an abnormal duct temperature indication on one of the pneumatic systems, accompanied by a faint acrid smell reported by a cabin crew member near the forward galley. Performance indications are normally normal for now, but the duct temperature is trending upward, and the cabin pressurization system, which depends on bleed air from this source, has begun showing slightly abnormal differential pressure behavior. The crew must now assess whether this is a contained overheat event or the early stages of a more significant bleed air leak, with low cloud, light rain, and the terrain of the Cape Peninsula and Hottentot Holland Mountains immediately in the region. Okay, so it's looks like we have an issue with one of the packs, air conditioning packs. maybe it's getting a bit hot, and looks like we're going to probably lose the ability to use that aircon pack. So let's begin the simulation, and let's see what it says. So in the initial actions here, it's given us where we are, climbing through 13,000. Basically what we've just spoken about. There's a bit of an instructor brief that you can click on here that explains the common traps in this phase. So it's just giving you phase by phase. It says rushing to diagnose before the aircraft is stable, missing memory items, making a radio call, confirming aircraft control. Aviate always comes before communicate there. All right, and it gives a couple of examples of where this scenario may come into effect. It's giving United Airlines 232, that was the Sioux City DC-10, and then the Hudson River as well. It's giving an example there of how critical this initial phase was. So let's have a look. Right, there's the map. So obviously just airborne out of Cape Town. So it's just showing the little red dot there, pretty close to Cape Town. And it's guesstimating a diversion airfield of Port Elizabeth. That's like probably a takeoff alternate. I know George weather been really bad. And then, of course, destination OR. They're probably using Lanseria as the destination alternate. So let's go through it, and taking into account that we've got this pack issue, and we now need to run through some type of analysis to see what we would do about it. So following a risk management model, the first thing always aviate. So what does aviate mean? It means that the aircraft's under control. And if you can engage the autopilot, so you have more brain capacity to actually concentrate on what the problem might be here. Are there memory items to complete? So I'm not a 737 driver myself, but this isn't intended to be type specific. So just think about your type that you're flying and answer that question. So are there any memory items to complete? I'm going to say no. In that case, navigate, regain situational awareness, ensure safe flight path and terrain clearance. So, yep, are we going to, nice to know what your MSA there is. I'm going to say 10,000 feet. There is some rather high terrain over there. But the idea here is to actually, from a practice perspective, go and open the JEP, have a look at what your MSA actually is, where they are. But I would say about 10,000 feet would be a decent altitude there. Not that you're going to descend randomly to that altitude, but we do have a pack problem, so we might need to. And then communicate. So are we going to give a mayday call here? Are we going to give a pan call? Or was it going to be more of a, we may not be able to climb to our a desired altitude, so just stand by. So I'm going to say stand by, but I'm not going to select a mayday or a pan scenario there. Also, no need to squawk 7700 in this case. But I might need to tell air traffic control something here. So I'll tell them, we are dealing with a pressurization problem and will need to level off at flight level 250. And again, type specific. The 73 may be able to climb well above that with one air conditioning pack, but I'm just being conservative here. I'm using the ERJ as a bit of an example. So 250 would be the highest altitude that I could use the APU on the ERJ. So that's why I'm saying, that's why I'm initially telling ATC, look, 250 is our highest level. All right, I'll just leave it there. And then I will say we may request higher again later on, or something to that effect, but just that's what I can think of at the moment. Complete or normal checklist. This is an important part of an RMM because once you're dealing with that abnormal, it's so easy now to actually forget that you have normal checklists to complete. So you might have a 10,000 foot check, a transition check, don't forget those. So even though you're dealing with this abnormal item, don't forget that you might have a standard normal checklist that still needs to be completed. Then it's got a time criticality assessment here. So is time critical? Are we limited on time, or do we have adequate time? I don't think time's critical. It depends. If that pack gets very hot or you actually have a leak, a bleed air leak or something, then you're a bit more critical. So I'm going to say time limited here. And what factors drive my assessment is, if this was a straight air conditioning pack, I'd say we have time, and I'd probably be inclined to say, look, we're going to carry on to Johannesburg with that. But if it's a leak, and if it's certainly if it's getting to the higher range, you're going to need to turn that pack off, and then you hope that that is the problem. I've actually had in a CRJ once, I had a pack run away in terms of temperature, and we got a cockpit full of smoke. Fortunately, it was on the ground at OR Tambo, but that pack ran away pretty quickly. So I'm going to say unsure at this stage if it's a simple pack fault or something to do with a leak. If it's a bleed air leak, then we may need to divert to our nearest suitable airfield. Nearest suitable airfield does not mean the nearest airfield. Johannesburg might be the nearest suitable airfield, even though it's far away. So this is what an RMM is all about, is sort of trying to take into account multiple things, and that includes weather, includes availability of emergency services or weather, anything like that. So I'm going to say, unsure at this stage if it's a simple, spell simple right there, pack fault or something to do with a leak. If it's a bleed air leak, then we may need to divert to our nearest suitable airfield. So now we've got to start making initial decisions here. Depending on the situation, select your next course of action. Continue en route, proceed to a suitable waypoint to hold, request radar vectors from ATC to a suitable air. What I'm going to say here is continue en route, because it is quite a long sector to Johannesburg. And although we're flying now away from Cape Town or away from our alternates, we're still not really sure at this stage what we're going to do about it. So I'm going to say continue en route. So obviously make sure that the FMS is correctly programmed for that. And we're going to go continue. Now we go to the assessment phase. Just as we did earlier on with that initial phase, there's a nice briefing there that you can have a squiz at if you want. All right, so in this assessment phase, it's all about trying to determine what is actually happening, what is going wrong, and with that, then we're going to action whatever we determine here. So we've already gathered some information from that initial phase, but now we need to actually really zone in on what the actual problem is. So Verify initial identification, confirm on relevant system indications. What do we think has happened? So this is up to you here a little bit. And of course, there's no right or wrong answer here. But in this case, I'm going to say, I think we have a pack that is about to overheat and potentially cause a leak. Just for the sake of the exercise, I'm going to say that. So I think we have a pack that's about to overheat and potentially cause a leak. It may shut down on its own. We may need to shut it down manually. Okay, circuit breakers in this case is not going to help. And now it becomes a time identify correct QRH procedure. So for the sake of the exercise, I'm going to say here, pack overheat / bleed air leak. Depending on your aircraft type, it'll be different for each type, of course, but again, use your own aircraft type, and if you have a QRH available, then at least you can have a look what QRH procedures are available to me in this situation, which really helps because it gets you to actually page through and use the QRH, and we see that so much where there's not enough familiarity with the QRH because you're not using it every day, so it becomes this book that you pull out once in a blue moon, and you're not familiar with it. So again, this program is all about, training this whole abnormal situation. So, let's stick with that pack overheat because maybe by this stage it started to increase in temperature as well, and we'll continue now. Action phase. All right, there's the identified procedure. In the RMM, it's got engine restart to consideration. That's not applicable to us. What other warning lights or system indications might you expect to see? So we may have, it did mention something about differential pressure will be affected, impacted in the cabin. We could possibly have I'm just going to say bleed air leak again because that is one of the messages that might pop up. Pack overheat, maybe higher temperature in the cabin. So again, this is getting you to think a little bit, just bringing out your technical knowledge on the aircraft. Of course, I'm being a little bit loose with this, but the purpose of this is to understand and work with the flow of an RMM, a T-DODAR, whatever you're using here, rather than being too specific. It's sort of pushing you through the understanding of what each phase is all about. The QRH, often depending on your type of failure that you've had, will have sometimes in it an add-on that you need for the landing. In other words, if you've got a flapless approach that you have to execute, of course you're going to use more of the runway. If you have a flight control malfunction, you'll use more of the runway, hydraulic malfunction. In this case now, we're not going to be impacted by runway length, so I'm not going to fill that in. I will just say runway wet here because it is raining there in Cape Town. It's got light rain. So I can't think off the top of my head how much runway is in Cape Town, but you can type that in and obviously make sure that you fall within your your limitations there. QRH restrictions, I'm going to say, right, flight level 250 due to the usage of the APU, because no doubt the checklist is going to tell you to start the APU. And on the ERJ that I'm used to operating at the moment, we'd be limited to 250. So that's why I'm putting that in. And if it is a leak, there's a very good chance that it says divert to your nearest suitable airfield. So those are the restrictions imposed by the QRH. Let's go to the management phase now. So here's our weather. Cape Town's not looking too bad. It's actually a lot better than it was yesterday. So I know I've got all the approaches available. I can go down to 200 feet in Cape Town. OR, everything's available as well. So I should have ticked that one. OR, again, everything's available, and the weather is much better. Port Elizabeth, clear skies. Yeah, PE is not too bad. I'm going to say all. I don't actually know what approaches are available there at the moment. But additional comments. Weather in FACT is poor. However, well within the limits in terms of performance and landing criteria. In this management phase, you'll then have a discussion, one of the more critical elements of the entire RMM. What's important in the discussion is that both crew members give their input, not just the captain. Both crew members need to add something to the conversation. All the constraints are acknowledged. In other words, you know, what's the benefit of going back to Cape Town versus diverting to Port Elizabeth versus continuing to Johannesburg? All the options discussed. And in this case, all three of those options would probably work. It's just what is the better one? And all the risks understood. Now, the risk here is that if that is a bleed leak, then you're going to need to divert pretty quickly, because having a bleed leak is no fun. Of course, yes, you've turned everything off, but I don't know, my thinking at the moment is probably to turn around and go back to Cape Town, if I'm being honest. And obviously it depends, landing weight restrictions, all the rest. But again, use your own aircraft and your own restrictions there to come up with that answer. So for this, when we consider, we obviously take into account the weather. Okay, so I'm just going to say FACT weather is poor compared to FAR. QRH impose nearest suitable airport requirement. Well, Cape Town or PE would work. I'm just going to put them both there. Technical support, we know we've got that in Cape Town and Johannesburg. ATC emergency services, yes, we've got that at all those airports. Group needs. Now it gets a bit more complicated. Where do the passengers want to go? Well, these passengers have paid for a ticket to Johannesburg, so they want to go to Johannesburg. Your company, they kind of want you to be in Johannesburg too, because the aircraft's supposed to go there. They've got maintenance support in Johannesburg, but you've also got maintenance probably in Cape Town as well. That's probably 6 of one, half a dozen of the other. Crew also want to be in Johannesburg. You know, they're probably ending their day. This is probably their 4th sector, the last one back home. Now to deal with this scenario, So group needs, sort of pushing you to probably carry on to Johannesburg. Individual needs, stress of crew and passengers. Again, this is something that I always think about, and I try and explain to non-aviators. You take a domestic operation like this. This is a SAF flight, and a fictitious SAF flight, not a real one. And you might have one of these pilots that has planned to fetch the kids from school at 4:00 this afternoon. It's now, say 1:30 in the afternoon. And now these things start running through your head. I can't pick up the kids. I need to arrange this. I need to arrange that. So a pilot is dealing with a huge amount of input, and this decision-making process is often complicated by external factors that have nothing to do with this flight. Now, pilots are ultimate professionals here, so this wouldn't, ordinarily be an issue. You would be able to block out a lot of that stuff and sort it out on the ground. But the reality of the situation is that pilots lead a very normal life as well, and they've got plans this afternoon, and sometimes those plans involve picking up loved ones from school or taking elderly father or grandfather to the hospital this afternoon, whatever it might be. And these individual stresses, whether we like it or not, probably do have an impact on the decision that ends up being made. So I'm just ticking all those off to say it's been thought of. And then we go into the decision-making matrix. So let's go through this here. I've got you 3 as low risk, 2 as medium risk, 1 as high risk. So to continue as planned from a task perspective. Now the task, remember, is your weather, QRH, technical, ATC. Right, so from a task perspective, I'm going to give it a 2 because to continue to Joburg is a decent distance, and if you do have a leak, it's going to impact you. From a group need perspective, which we know is, what do we want to do? We know we want to go back to OR. And I'm going to give this one a 2 as well because we've already discussed that the individual needs play a big role here. For this one, I'm going to give 2, 2, and 2. Port Elizabeth's quite still, it's a decent distance away. You don't really want to go there. You're going to divert and have to make your way back to OR later. They might have to send other crew member down to do it because you might be out of time and duty. Return to departure. I'm going to give this one a 3. Group, I'm going to go 2 here. And individual, I'm going to go 2. And so I've got 2 obvious ones here. So diverting is not a good idea. Continue as planned is giving a relatively low risk. Returning is giving the same. However, in this case, I'm going to say, right, after we've had our discussion and we've been through the risks and we've spoken about the task, individual, the group needs, and we've both, the captain and the first officer, have both given their opinions on the situation. You're going to come up with a decision. And I'm going to say for the argument of this exercise, we decide to return. Can't spell today. Return to Cape Town based on the QRH leading us to divert to the nearest suitable airfield. And despite poor conditions in FACT, they are still within the limits of the aircraft and landing criteria. So that's my decision. And I'm going to confirm that decision. Let's continue. Now we implement that decision. Okay, so here it's got your decision from the management phase. We decide to return to Cape Town. It's given us our safe altitude, our progress so far. Again, there's a little brief on this section that you can have a look at. And now we need to implement. So how do we implement a decision? Well, we need to notify ATC now of our decision and our intentions. So we tell ATC we would like to return to FACT, but they're still pretty close. And this may have taken 20 or so minutes. So I don't want to tell ATC now we're ready to return back, because we've still got a little bit to sort out. We've got, program the FMS again. I must speak to our cabin crew, speak to passengers, let our company know what's happening. So I would like to return to Cape Town and preferably hold at 50 nautical miles or something, that somewhere that is relatively close so we can get back quickly. But I'm not quite ready for the approach yet. We will let you know when we are ready for the approach, or detail complete, something to that effect. All right, we'll then need to reprogram the FMS. And then I'm just going to say, I forget the name. It used to be called, was it Golf Echo NDB? I forget, but probably hold at Octed, or, one of the, I think Octed, I think, is probably the right one. All right, now we need to speak to our cabin crew. So do you do a NITS or a test briefing? Let's say NITS. Nature of the intention, I'm going to say pressurization issue. Intentions, return to FACT. Time, I'm going to give them 15 minutes to get the cabin ready. And we do not expect to evacuate. Okay, you can go into as much detail here as possible, but to save you a bit of boredom here, that would be a NITS briefing. And then you'd prepare for the approach. Okay, obviously you're going to review the systems again to see if you've been impacted any further. And I learned this briefing method from Laurie Graham. So nice way to brief. You brief the Jeppesen chart, you brief terrain, you brief weather, you brief your operational restrictions, and then you brief how much fuel do you have, how much fuel do you need. And we can then prepare for the ILS in FAC. I forget what was it, probably runway 01. And preferably radar vectors. Save a bit of time. ATC in Cape Town's normally pretty good. Okay, and final preparation. Do we need emergency services? I'm going to say no. And we then commence final approach, and that's basically where the scenario ends. So obviously I've gone through it here relatively quickly. The idea here is not ultimate perfection. There's no right or wrong answer here, but it's all about developing the skill set around dealing with an abnormal situation. And in this case, we took a real flight that was a fly-safe air from Cape Town to Johannesburg, and we had this issue on the climb. It was a pack issue that could have become a pack overheat or a leak. So the decision that I made was to come back to Cape Town, despite the weather being on the poor side. So it gives you a bit of a link as to how you got to your decisions, and then it gives you the option to submit a analysis by Bryan AI, which will actually give you an analysis of your decision making. Now, where this is getting its info from was from all the simulator sessions we've done over the years. I saved a lot of the faults that we saw the pilots make, and then I plug that into this AI that hopefully uses that information to come up with the analysis to give you an idea as to what your decision-making process was like. And of course, it's not replacing an instructor. It doesn't even mean it's right. It's just giving you an opinion. And let's face it, for something like this, any scenario like this, and anyone that's been a management pilot before, you'll know that oftentimes one of your crew members makes a decision and then you say to them, but why didn't you do this? Or did you consider that? And a lot of the sharper guys say, you know what, Bryan, you weren't there. At the time, this was this felt best. And I'm not going to argue with that, because I 100% agree. When you're there and you're dealing with the situation, you're dealing with these multiple things that sometimes are quite difficult to articulate after the fact. You land after and say, geez, did we consider this? Should we have done that? But at the time, this felt like the best decision. So yeah, it gives you a bit of a breakdown. It gave us 7.5 out of 10. What we did well, areas for improvement, sharp and early threat identification, terrain and pressurization were underweighted at 13,000 feet with rising terrain to the north. The most immediate threats before diagnosis are proximity to terrain. Okay, yeah, fair enough, but we're climbing away pretty quickly there. DMM scoring lacked differentiation and rationale. Fair enough. DMM analysis, threat and error, system knowledge assessment. The more info you put in, the better it's going to score you. The right decision for slightly fuzzy reasons is still a good outcome, but in aviation, the robustness of your decision process matters as much as the outcome itself. Your diversion to Cape Town was correct, but if a company safety manager, a captain, or an investigation board asked you to walk through why option 3 scored higher than option 2 on the DMM, could you answer that clearly? So it's basically saying, why did I choose Cape Town and not Port Elizabeth? My idea there was you're closer to Cape Town, and the passengers, although they're not where they want to be, at least you've taken them back to somewhere familiar, whereas Port Elizabeth, you understand the complexities of these things. But now the whole idea is to say, okay, fair enough. I want to go and try that again, please, and go back to the beginning, reload it, and let's go do another session, start fresh. And next time you can click on the T-DODAR if you want, choose a different flight. We can even go to Dubai and pick a flight out of Dubai with a totally different scenario, maybe an airspace closure or something like that. And I think we've even got that. Yeah, we got airspace closure option in here, or you can just choose something random. And the idea is to just get comfortable with the decision-making process involved in airline operations. It is complex. It does require, for me, I learn by repetition. If anything, I have to just repeat it until I understand. I'm not one of those guys that gets told something once and it sticks in there and I can go and do it. I need to do it. I need to make mistakes. I need to learn from the mistakes. Then I need to try it again, get a bit better. And then eventually the penny drops, it clicks, and I now understand the process. And in all honesty, for me, I actually only really understood this process after becoming an instructor, because sitting in the back of a simulator and you watch these things play out, then I started to really understand how important this was. Hence the development of this little bit of software that hopefully may help a couple of pilots that battle with the risk management and decision-making process of airline operations. I hope you enjoyed it, and I'm going to keep putting more and more videos like this on this channel. Share it with someone that you know that might benefit from it, please, and don't forget to subscribe to the channel. Thanks for watching. Cheers.